Alright people, this is Daniel, and starting from this video we're going to start rolling our sleeves and diving into more advanced Scala stuff. This lesson will be fairly easy, and you know by now that Scala is a sweet expressive language full of syntactic sugars which make our lives very, very easy. But in this video we'll look at even more syntax sugars which make Scala such an expressive language. We'll make use of most of these sugars throughout the course, and I wanted you to be aware of them as you may see them in production code and you may wonder how the heck does this code even compile. Cool, no more introductions. I'm here in the IDE and I'm going to create a new Scala application specifically for this lecture as before. So right click new Scala class and I'm going to create a new Scala object called dark sugars. I'm going to make this an object and make it extend app so that we can run our code. Switching to presentation mode. Cool, let's get right into this. So, syntax sugar number 1. Methods with single parenthesis. And methods with single parameters can actually be called in a very special way. So if I define a single argument method with an argument which is of type, say, int. I don't really care what the type is, and it returns, again, something that I don't really care about. And say this guy returns n little ducks. Okay, we can call this single argument method in a very special way. If I say, let's say, description, for lack of a better name, we can call single arg method, and instead of calling the method with a argument in parentheses, we can actually call the method with a curly brace and supply the parameter here as an implementation of this little code block. So we can say a single parameter method, and we can actually, I don't know, write some code, and at the end return the result. Okay, so this is a syntactic sugar that allows us to write Scala code with curly braces in a syntax very similar to Java or C++. To give a couple of examples in practice, so the try apply method, for example, if I say a try instance is try, and in practice we often use the try apply method with curly braces like this. Alt enter here to import. So this is actually a code style that is often used in practice because it's very reminiscent to Java try curly brace. And I don't know, we can throw exceptions, we can do whatever we want. But just so you know, if you see this in production code, that's actually the apply method from try and applied with this argument. Okay. That's one example. Another example is collection functionals like map, flat map, and filter. So if I say list123, for example, and I say map, again, a code style that's often used in practice is saying map, and then we can say a curly brace here, and we can put in the argument, and let's just say, I don't know, x+1 or whatever complex lambda implementation. But this is code style that's often used in practice, and for people that are not really accustomed to this syntax sugar that I'm presenting right here, you may scratch your head and wonder how the hell does this actually compile. So that's one syntax sugar. We're going to talk about quite a few more. Syntax sugar 2. Instances of traits with a single method can actually be reduced to lambdas. This is called the single abstract method pattern. So if I declare a trait, let's say action or something, with a single method called act, let's say it acts on an int and produces another int. Now, a normal way of instantiating this trait would be to either extend this trait with a non-abstract class or implement an anonymous class here. For example, if I say an instance would be of type action, would be, say, new action, and on the spot I could implement override act, and let's say this is x plus 1. But as you may notice, if I hover over this new action expression, the IDE is already suggesting that I convert to single abstract method. What does that mean? The single abstract method basically means that I can reduce an instance of this single method trait to a lambda. So if I say a funky instance of type action is, and I can supply a lambda here, say x int arrow x plus 1. And this is a valid conversion because the Scala compiler figures out that this is a function 1 type, which can be attributed to the act implementation of an action trait. So the compiler does a lot of magic here to actually allow this lambda to single abstract type conversion. As we're going to see in the upcoming concurrency section, an example here is instantiating traits with runnables. If you've written for the JVM before, or if you've done a lot of Java, you know what runnables are. They're instances of a trait or of a Java interface that can be passed on to threads. So if I say val a thread equals new thread with new runnable, and implement a method run here on the spot, say println hello Scala, that's a valid thread creation. But we can also say val a sweeter thread is new thread with a lambda that takes no parameters because the run method here takes no parameters, and say println sweet Scala. All right. The first example here, the normal way of instantiating runnables, is actually the way Java does it, but Scala is so much sweeter. This pattern also works for classes that have some members or methods implemented, but only have one method unimplemented. So if I say abstract class, let's say an abstract type, and this guy has a method called, let's say, implemented, which is of type int, I don't care, and let's say returns 23 or some other value, and has an abstract method f, which takes a value a of type int and returns, I don't know, unit. Okay, this guy is unimplemented, and I can actually assign a lambda to this abstract type. So if I say val an instance, an abstract instance of an abstract type equals a int, I don't know, println sweet, that's also acceptable. All right, so when people see this kind of assignment, they usually freak out because they assume something with implicits is actually happening. We're going to dive into implicits as well. It's one of the scarier Scala chapters, but none of that is happening here. It's just a language syntax sugar. All right, cool. So let's move on to syntax sugar number 3, which is the : and hashtag : methods, which are special. What do I mean? So when I say, let's say val prepended list, which is 2 : list of 3, 4. You've seen the : operator when we talked about lists. Now, have you wondered how this thing actually compiles? Because if you sit for a second to think about it, Infix methods are actually converted to first object dot method and then second thing, which would be normally equivalent to 2 dot : and then list 3, 4. So that's what we would normally have with our current understanding of Infix methods. But that's absurd because there is no : method on int. In fact, the compiler rewrites that as list 3, 4 dot : 2. And you may wonder, how on earth? Now, the answer lies in the Scala specification, which says that the associativity of a method is determined by the operator's last character. So last character decides the associativity of the method. So if it ends in a colon, it means it's right associative. If it's not, then it's left associative, which means that it has the normal method behavior. This allows the compiler to be able to rewrite such operators in reverse order, because when you say 1 colon 2 colon 3 colon list 4 5, that actually means that because of this operator being right associative, this operation evaluates first, and then this expression is evaluated next, and then this whole expression is evaluated finally, which makes the compiler rewrite that as list 4 5 dot colon colon 3 dot colon colon 2 dot colon colon 1. We're going to dive into streams very shortly. If you say, for example, a method called arrow colon, something like that, with a value of type t, which returns another MyStream of type t. And I don't know, you can provide an actual implementation, but I'm just going to return this same instance. All right. Just for the sake of the syntax sugar here, you can say val MyStream is 1 arrow colon 2 arrow colon 3 arrow colon new MyStream of int. And that would be perfectly viable because the arrow colon operator here is right associative because it ends in a colon. So as you see, in reality, the colon colon and hash colon colon methods, the hash colon colon, by the way, being the prepend operator on streams, they're not special by themselves. They're only special because they end in a colon and are thus right associative. All right, next syntax sugar. Syntax sugar number 4. And this is not actually a syntax sugar, but more like a language feature, and this is called multi-word method naming. Let me show you what I mean. So if I define a class teen girl with a name, I can define a method. Watch what I'm writing. I'm defining a method called, and I'm going to start naming the method with backticks, and I'm going to say and then said backtick. And that means that I have a method here composed of 3 words. And let's say I have a gossip parameter, which is a string. And then let's say print line name said message. And let's pull some $signs here to interpolate the, not the message, but the gossip. All right, so the spotlight here is on the very fancy method name here with backticks and multi-words. And of course, I can infix this method because it has a single parameter. So this leads to very natural-like expressions. For example, if I say val Lily is new teen girl with name Lily, I can say Lily backtick and then said Scala is so sweet. And this is a perfectly acceptable expression because this is a perfectly acceptable method name. These method names are rarely used in practice, but if you do see them in practice, don't get scared. All right, next syntax sugar. Syntax sugar number 5. All right, and this is with generics. And we're going to talk about infix types very shortly. All right, so if I declare, for example, a class composite, like map with 2 type parameters, like A and B. All right, this is similar to map, right? The map type has 2 type parameters, keys, and values. I can declare a value of type composite, which is composite of int and string, for example, equals whatever. All right, and this is a perfectly acceptable type because this is the normal way that we write generic types, but we can actually write them in Infix. So we can say int composite string. In the same way that we can infix method calls, we can also infix generic types. Now, if you remember, type names are also very permissive. So if we declare a class, say, long arrow with A and B, you can define a val, call this towards, for lack of a better name, and the type could be int long arrow string equals whatever. And this is perfectly compilable code. This thing is an infix type, which the compiler reduces to arrow of int and string. We're going to use these very primitive type names when we talk about type level of programming way at the end of this advanced course. Next sugar, syntax sugar. Where are we? Oh, syntax sugar number 6. Number 6 is the update method, which is also very special, much like apply. What do I mean by that? Let's say, for example, I have an array. Which is, say, array of 1, 2, 3. I don't care about the contents. I can actually say an array with parameter 2 equals 7, which is quite a bit of magic that the compiler actually works for us. This actually gets rewritten to an array.update, and the update function takes 2 parameters. The first is the index that we want to modify the array, so 2, and the second argument is the value that we want to put in. So this is actually what the compiler rewrites this expression to. Update takes 2 parameters and returns unit. Update is very used in mutable collections. So if you want to implement your own mutable container, you might want to consider providing an update method. So now you should remember 2 special functions in Scala instead of 1. If by now you've used apply as a way of calling, quote unquote, calling objects like they were functions, now you also have update here because it's very similar in syntax. So now remember, apply and update. All right, and final syntax sugar. Again, for mutable containers, we have setters. Now, what do I mean by that? Let's prove by example. Let's say we are some rockstar Scala programmers and we want to create a mutable wrapper over an int. So let's create a class called mutable, and we want to create a private var internal member, which is of type int, and let's say its value is 0. Private for object-oriented encapsulation. Let's respect the object-oriented principles, people. All right. Now, if this class called mutable has 2 very special methods, then I can actually modify this internal member in a very cute syntax. So watch what I'm writing. So if I define a method called member equals internal member, all right, so this is the getter, so to speak. And if I also define a setter, which is in very close relationship with the getter in that I say member and then I suffix it with an underscore equals, and then I pass it a parameter, let's say value called int, and then this returns unit. And the implementation should be internal member equals value. So basically, this is the setter. Then, if these conditions are met, so if I declare a getter and a setter, which are in close relationship, in that the setter is the suffix of member with the underscore equals, I can create a mutable container, which is new mutable. and equals, of course. And then I can say a mutable container dot member equals 42. So the Scala compiler actually rewrites that as dot member underscore equals of 42. So this is rewritten as a mutable container dot member underscore equals with parameter 42. Okay, so this is the syntax trigger that only happens if I declare a getter and a setter called member. Alright, so in this video we found that Scala is even sweeter than we were even aware. First, we found that single arc method calls allow for curly braces, and we saw some examples. We found the single abstract method pattern, which says that types with a single abstract method can be reduced to lambdas. We found that the methods ending with colon are special in the sense that they're right associative, and we defined our own and used it. We now know that methods ending in colon are right associative and left associative in any other case. But wait, there's more. We found a very cute way of naming our methods, which makes Scala even more expressive than we were used to. Then we talked about Infix generic types, which combined with the very permissive type naming allows for very expressive types as well. We're going to use those in the type level programming section at the very last part of the course. We talked about update as a very special method, as the compiler rewrites quote-unquote callable assignments into calls to update. Then we also found about setters for mutable types, and we had an example of our own, and then we saw it in action. Alright people, this is Daniel. I hope this was a good warm-up for you because there's more advanced Scala coming up in the next video.